video on absolute value for our Unit 8 test preview, and I'm going to do combine a couple topics here. So if you're here to watch the approaching proficient video, I will give you a number that you can go just fast forward to that. But otherwise, I'm going to start here with below proficient. And here it says to fill in the table for the following equation. And they've given us the following values for x. I'm going to highlight those in yellow. And we're putting those in for x. And so what that looks like then is we'd say, like on the top one, we'd say negative 15 plus 2, where there was an x, I put in that value of negative 15. And negative 15 plus 2 then is equal to negative 13 in the absolute value. Now that you have evaluated, so you have to always do what's inside the absolute value symbols first before you take the absolute value. But then you need to remember that absolute value is the distance of a number. I'm going to abbreviate distance of a number from 0 on a number line. So imagine if you were at negative 13, I'm here at 0, and over here at negative 13, 0's here, and I'm at negative 13. How far am I going to have to travel to get to 0? And the answer there is always positive. So this is going to be 13 units, because distances are not negative. Differences are always positive. And so the absolute value of negative 13 is 13. And then we'll do negative 7. So we've got absolute value negative 7 plus 2. So it's same as before, but now I'm using the value negative 7. So negative 7 plus 2, the absolute value negative 5, and the absolute value of negative 5 is 5. All right, moving right along. So absolute value negative 1. Well, got absolute value negative 1 plus 2. Again, negative 1 is the value I put in there for x. And so negative 1 plus 2, that's absolute value. 2 minus 1 is 1. Absolute value of 1 is 1. Always positive. And then let's say 5. Absolute value of 5 plus 2. Where now I put in that value 5. So here, 5 plus 2, absolute value of 7, and that is 7. So here's 7. And then we've got absolute value of 8 plus 2, and 8 plus 2 is 10, so the absolute value of 10, and that is 10. So those are our values. That's how you would do if you just have to substitute. And remember, you have to do what's inside first. Then once you have it down to a number, find its absolute value. It's always positive. And then if there's anything on the outside to do, you'd basically just following the order of operations, but the absolute value brackets would fall under P of PEMDAS, like parentheses. You got to do what's inside first before you find the absolute value, and then before you would continue on down the order. Okay, so on this other side here, on the other side, we've got key features of a graph involving the graphs of absolute values. And notice it's V-shaped. If it goes all the way to the edge of the graph, we're going to assume that it continues. So we'll put little arrows there just to remind us this does continue. And that means it continues off to the left all the way to negative infinity. Domain are the x values. On the right, it goes towards positive infinity. On the left, it goes towards negative infinity. And so it's negative infinity to positive infinity, everything in between. It's all real numbers. All right, and then its range, well, the range is the y values. And so it's up and down, whereas the domain was left and right. And so because we're doing an interval, it always goes from the least to the highest. So this is going to go from the bottom to the top. And that's how we're going to kind of write this. Well, the least value, because the arrows are facing down, it doesn't have a least value. It goes all the way down towards negative infinity. But it does have a highest point, and that is where y equals 3. And so I would say this goes up to 3. It does touch 3. This point has coordinates of -2, 3, and that means 3 is included. So we use a bracket at 3. Now, direction, how does this open? Well, it's opening down. If it was like this, it would be opening up. All right, vertex. I already listed it out there. It's the highest point or the lowest point, depending on if it opens up or down. This is -2, 3, so that's our vertex. It's this point right there. Okay, increasing. Increasing means it's going up. So like if as you move from the left to the right, and this is going up here, and so increasing, and then decreasing, it's going down as you move to the right. So it's decreasing over here. But you're using x values to describe where that happens. And so this value right here of x is, let's rewrite this. This value here of x is -2. Over on this end, you might be tempted to say -11, but it actually just continues towards negative infinity. And over here, towards positive infinity. Again, it's going to the right. So you're talking about x values. And so here, I would say this is increasing. And over here, it is decreasing. And then you can just write that down. So if you label this like this, you're going to find that this is really not too hard. It's increasing from negative infinity to -2. And then it's decreasing from -2 towards positive infinity. You're just listing those values between which here it's decreasing, so it's -2 and infinity. On increasing, it's from negative infinity to -2. And just read it from left to right. Okay. All right, we'll see you in the next video.